Good afternoon, everyone. Welcome back to Tech Talk Tuesday here at Treadwell. Edward Titley's my name. If you've joined before, thanks for your support. And if you're joining for the first time, welcome. We hold these sessions every second Tuesday this time, so that's 1:30 in New South Wales at the moment. And we run through a variety of things, design standards, project examples, product use cases, all that sort of stuff. Today, we are having a look again at AS 2156.2, which is a standard relating to walking tracks and those sort of things. National parks, public access, that sort of stuff. Now, a bit of housekeeping before we start. We're not Standards Australia, so I'm not going to be able to tell you what was the intent behind writing a standard or what they meant when they said a certain thing or anything like that. And everything we discuss today is obviously general advice or commentary. We're not discussing project-specific applications. We're not confirming compliance of specific projects, any of those sort of things. Happy to have those discussions around project-specific matters. However, we'll engage separately with you on a case-by-case basis for that. Just lastly, before we begin, we've got a Q&A session at the end, but the Q&A window is open now. So if you hit Q&A on the top of your screen, you can drop a question in that chat at any point in time. We'll address it as we're going if we can, or we'll deal with it at the end, or we may have to take it on notice depending on what your question's relating to. So that's it. Without any further ado, we'll get straight into it. So AS 2156. AS 2156 specifies requirements for the structural design of walking track structures, protect natural and cultural assets, and for use as aids to recreation in outdoor areas where the environment is the focus of recreational activities. Pretty straightforward there. Structures that are covered under AS 2156.2, things like boardwalks, galleries, pedestrian bridges, viewing platforms, barriers, stairways, that sort of thing. Now, it's important to note that what's not included in this is not structures to carry livestock or vehicles, including light maintenance vehicles, bicycles, and that sort of thing. They are not part of the scope of AS 2156.2. The objective of the standard, as per AS 2156.2, is to provide designers and builders with design and construction requirements for non-habitable outdoor structures intended to protect the environment and to be used as recreational facilities. So today we'll have a bit of a look at loading and a bit of a look at barriers and fall protection, that sort of thing. So firstly, section 2 of the standard is design of structures. Structures shall be designed in accordance with the applicable Australian standards. Design load shall be given in appropriate parts of AS 1170 unless otherwise stated in this section. So just draw your attention to that as far as also being familiar with AS 1170, which I'm sure most of you are. Now, limit state designs, once again, this is probably all pretty obvious stuff, but just so we're all on the same page, the structure and its members shall satisfy the serviceability limit state requirements outlined in AS 1170. And for track classes 4 and 5, set serviceability limits to ensure that deflections will not prove uncomfortable and the structure can absorb deflection without causing damage. And strength and stability limit states structure and its members shall be designed to put the combinations of factors and factored loads and forces from AS 1170.1 for strength and stability and follow the live load combination factors outlined in 1170.1 for strength and stability limit states when applicable. So we're not going to look at AS 1170.1 today. We have looked at it, touched on it briefly, and some other design standards, design of these sections, I should say, around floor loadings and that sort of thing. But I'm sure most of you, especially if you're structural engineers, are well familiar with AS 1170.1, but I will just point out that this standard sorry, hopefully everyone can still hear us, slight headset glitch. Just note that obviously the standard refers to 1170.1 extensively, and you should follow the guidelines in that standard in AS 1170.1 around live load combination factors and that sort of stuff. Now, class 1 and 2 walking tracks is the first thing we'll address. And according to AS 1170.1, for public assembly areas in track classes 1 and 2, either a 4 or 5 kPa UDL and a 4.5 kilonewton concentrated load. When calculating the floor loads using 1170.1, the live load reduction R shall be taken as 0, and design, distributed, uniform, and concentrated load shall be considered separately, and the design carried out for whichever gives the more adverse effect. From our experience, and this is once again not project-specific advice or anything like that, from our experience, typically your concentrated live loads will produce the most adverse effect. Occasionally that'll be a line load if that's applicable, but typically these, in this instance, the 4.5 kilonewton concentrated load will produce a more adverse effect than a 4 or 5 kPa UDL. Now, track classes 3 and 4, 4 kPa for viewing platforms and 3 kPa for access ways. So your standard boardwalk would have a load of 3 kPa. Your viewing platform, so an area where persons would congregate, would have a load of 4 kPa. For a class 5 walking track, we'd be looking at a 3 kPa load for platforms, 2 kPa for access ways or your regular boardwalk structure. Now, once again, use a concentrated load of 1.4 kilonewtons over 75 by 75 mil area at most adverse positions or known positions, so where that load could be actually applied to the structure. In this instance, I'd expect to see a more adverse effect from a 4 or 3 kPa UDL, but potentially I'd probably expect the 1.4 kilonewtons to produce a more adverse effect than 2 kPa. And lastly, wire crossing is not really applicable to what we do here at Treadwell. Just for the record, 1.1 kilonewtons per meter on each wire. And lastly, as per the earlier track classes, so 1 and 2, the design loading, so our UDL, uniform line load or a concentrated live load will be considered separately. Whichever produces the most adverse effect is what we would consider. Now, lateral loading, so things like wind load, earthquake load, and so on. So we need to also consider effective wind as per AS 1170.2 and earthquake loading as per AS 1170.4 as applicable, and the movement of people, which should all be considered separately. For the movement of people, lateral load should be taken as 250 newtons per square meter of plan area. So once again, that should be reasonably straightforward. Now, as for snow and ice, not applicable to a lot of parts of Australia, but applicable to some parts, AS 1170.3 refers to snow and ice loads, and we should consider, as per that standard for our walking track design, allowances should be made for the containment of snow trapped between handrails, barriers, and other built impediments. The effect of snow and ice build-up on wind loads shall always also be considered. Something to think about if we've got quite a close balustrade and we expect that ice or snow may build up on that, or we've got horizontal rails as part of that balustrade, we also might see snow and ice build up on that. Just had a note come in from Kane. Thanks, Kane. As you're probably most of you aware, if you're not aware, then we'll point that out now. AS 2156.2 was officially withdrawn on March the 30th, 2020. That's a very good point. Well, it's a valid point you make. However, as Standards Australia say, that does not impact the document's availability or ability to use the document. It's withdrawn because Standards Australia obviously feel it's no longer relevant, but also it won't be maintained or updated. However, it's still possible for it to be used in the event there's not a replacement. Now, design of supports. Excuse me. Foundation design based on limit states approach. So once again, they're combinations from AS 1170.1 and a short-term multiplier of 1.0. And for design based on nominal nodes, sorry, nominal loads refer to specified nominal loads in clauses 2.3, 2.4, and 2.5, which can be considered separately. So they're not going to read you the full standard, but we'll just draw your attention to that section. Next up, live loads on barriers. So once again, as per AS 1170.1, for track classifications 1 and 2, the load for those barriers is specified. Other classifications follow this table 1 here. So need to be ensure we're clear. This table applies to classes 3, 4, and 5, and AS 1170.1 provides the loadings for classifications 1 and 2. So I'm not going to read this table out to you all. We'll just draw your attention to the top rail loadings. Well, I'll just briefly mention the loading. So horizontal and vertical on the top rail, 0.75 kilonewtons per meter, 1 kPa horizontally on the infill, and 0.5 kilonewtons in any direction. And likewise with access structures, so rather than viewing platforms, 0.36 kilonewtons per meter and a 0.75 kPa loading on the infill, 0.25 loading in any direction on your infill. Load combinations for barriers, I think we touched on that. As usual, wind, earthquake, and the specified loads may be assumed to act separately, designed based on whichever gives the most adverse effect. So same as the things we've mentioned. Now, safety from falling. Once again, this is kind of something difficult to run through in this forum without being on site and taking measurements and those sort of things. But in any case, we'll touch on it briefly. So this section provides criteria for the provision of barriers to reduce the risk of falling. Where the effective fall height exceeds the value given in table 2, so that's HF here, 1, 1.5, and 3, then there's barrier types that are provided. So track class 1, 2, 3, 4, and 5. So you'll note here that for effective fall height of 1, no barriers required according to for track class 4 and 5. For effective height of 1.5, none is required for class 5. However, for here we're class 3 and 4, type C and D barriers respectively are required. However, they can be placed on one side only. And for effective fall height of 3, as per for track class 4, once again, may be provided on one side only. But for class 5, a type E handhold may be placed on the opposite side of the structure to the fall hazard and may not be continuous. Assessment of full impact surface. This table here, table 3, helps us to make an assessment of the risk or the impact of a fall. So we've got our categories here: benign, favourable, unfavourable, and hazardous. Brief description, and then the taking this value here of H. We've got a variety of examples here: deep moss, soft vegetation, so on as benign. Favourable, loose gravel and sand, or water with a reasonable means of exit, or grass. Unfavourable, sharp vegetation, jagged stones, etc. And then hazardous being extended falls, so where the slope exceeds 35 degrees, or swiftly flowing water, and so on. So now we'll look at some barrier types. This is a type A barrier, quite similar to what you've seen if you've looked at AS 1428 as far as accessible walkways and barriers for those. No openings anywhere below the top rail that'll allow the passage of a severe 125 mm diameter, and then between 150 and 760 millimeters above the deck level, no components providing a tow hold. And you can see here we've got that with our vertical balusters, pickets. And then for steps, the training, they're only formed by the riser, tread, and bottom rail at the open side. Once again, our 125 mm diameter sphere can't pass through it. And the other aspect is that for 1,000 mm that our minimum height is 1,000 mil. I'll mention here it's not included as part of this standard AS 2156, but I'll draw everyone's attention to the need for sometimes for structures to be bike safe. Now, typically a bike safe barrier needs to be about the 1,400 mil height. So I'll just note that there's a few other aspects to it as well, which we can cover in a separate webinar. However, just draw your attention to that height matter. The type B barrier, once again, 1,000 mil high, and we can have, once again, 125 mil openings. However, it is acceptable in this instance for us to have our infill running horizontally. No openings greater than 125 mil. However, it's acceptable to have our infill running horizontally. And as per the type A barrier, also for the steps, so the 125 mil sphere not passing through the opening that's made by the bottom rail and handrail and the stair treads and the risers. And then the type C barrier, minimum height 900 mil, openings restricted to 500 mil vertically and 300 mil at the bottom. As you can see, here's the 300 mil max to the mid rail, 800 mil max to the top rail, minimum height 900 mil, and there's no restrictions between vertical sections, space-wise or spacing-wise, other than obviously structural constraints. And an infill material is allowed if suitable. So noted on that. The type D or E barrier. Type D barrier is a single handrail at the minimum height of 900 mil, which may be solid or may consist of rope, chain, or wire. But I'll draw your attention once again to the fact there's no mid-rail, there's no infill. Or a type E is what we're referring to as a handhold, which may not necessarily be continuous. Could be separate handholds, or we could have rope, chain, or wire once again, and we could mount that to a wall or rock face or something along those lines, but just as a means to hold on. Now, brief commentary on stairs and ladders, and I'm sorry we're running quite over time here. Stair treads and their support structure should be designed according to the live loads given in AS 1170.1. Ladders and fixings must be designed for a concentrated live load of at least 1.4 kilonewtons, with spacing determined by expected usage. And the style should be spaced between 380 and 525 mil, so that's the width of your ladder. And then rungs between 250 and 300 millimeters apart. And lastly, stairways and landings. For stairways, the maximum number of steps between landings shall be as given in table 4, and landings is a minimum of 900 mil long. Because we haven't got table 4 in here, as I said, we're well over time, so I'm sorry. Just lastly, the preferred range of slopes here. So for classes 3, 4, and 5, we'll start at the top right. Rung ladders between 70 to 90 degrees, with our preferred range 70 to 75. Classes 4 and 5, we can have step ladders between 60 and 70 degrees. Between 45 and 60 degrees is what's considered the unsafe zone. So it's not ideal or not safe to have access means between those slopes. And then between 20 and 45 degrees stairways, class 3, 4, and 5. But class 2 stairway has to be between 30 and 38 degrees. However, that is the preferred range for all classes. And lastly, walkways. So classes 3, 4, and 5 walkways this is up to a 20-degree slope. However, their preferred range for 3, 4, and 5 is up to 10 degrees, and up to 2 for class 2 up to 7 degrees. So to note there as regards how we're going to access between levels or something like that. Styles of crossing fences are allowed in classes 3, 4, and 5, not exceeding 1.2 meters in height, and supporting structure designed for the specified loads, and the vertical handhold required for maintenance of balance, and the style height limited to 1.2 meters, as we've mentioned. Something to take into account here. That's it. Sorry, we've gone for 20 minutes. So I apologise for running over time. Thanks all for joining. Hope it was of some value. Stay on for a couple of minutes if anyone's got any questions. Any other webinar ideas, always open to those, as I mentioned earlier. It might be a good webinar opportunity to anything you'd like. Feel free to bring it up, chuck it on the chat, send it to us as an email, anything like that. Always up for ideas. And if you've got a project you'd like to discuss, drop us a line, hello@treadwellgroup.com.au, or give us a call, 1-800-246-800, or 0800-244-600 for those in New Zealand. It's 1:51 here where I am. If there's any questions, we'll stay on for a minute or two. Feel free to ask. If we can't answer them here, we'll take them on notice, but hopefully we can answer the simple questions you've got. If there's no questions otherwise, thanks for joining once again, and we'll see you in a couple of weeks for another Tech Talk Tuesday. And just questions for the presentation. If you could just drop an email to hello@treadwellgroup.com.au, we'll be able to send it back, the presentation back to you. Otherwise, you'll be able to find a video of this on our YouTube channel or on our website under the resources section. But if you just drop us an email, we'll be happy to send the presentation back to you. Seems to be about it. Thanks again, everyone. Sorry for running over time. Hope we didn't bore you all too much. And we'll see you again in 2 weeks. Thanks very much.